Now that we have discussed the shape of the different conic sections, we're going to start by calculating the parabola. Now, you worked with parabolas in college algebra, but the parabolas we worked with would always facing up or down, as our equation was, for example, if we had y equals x squared, then that was my parent function, that parabola facing upward. If I had y equaled a negative x squared, then that flipped it so that it was upside down. But those were, we would take that vertex and we would shift it left, right, up, down, but the parabola always focused up or down. And notice that when we had those parabola that were facing up or down, it was always an x squared term. We talked about the fact that if we did the inverse of this and we flipped it to make it a y square, for example, then it's going to focus to the left or the right. That's no longer a function. Now, we are not worried about whether or not it's a function. We're worrying about graphing different parabolas. Okay, you're going to have some new vocabulary with these parabolas. So let's read our definitions closely. A parabola is the collection of all points P in the plane, so in a flat surface, that are the same distance d from some fixed point F as they are from a fixed line D. So we have this point F inside my parabola, and this point F is called our focus. F is for focus of the parabola. So F is for our focus. And then we have this line D back here that is called our directrix. Directrix. Now, our directrix, line D, is perpendicular to a line of symmetry for the parabola, and the line of symmetry goes through the focus. Your line of symmetry, axis of symmetry, here is axis of symmetry, AS, and that cut that off. Axis of symmetry goes through the vertex of the parabola and through the focus, and it is perpendicular to the directrix that is back here. Now, there's some interesting things about the way these relate to each other. The distance from the vertex to the focus is the same as the distance from the vertex to the directrix. And my parabola is defined as this distance from the focus to this point is the same as the distance from the focus to a point on the directrix. So the set of all points P for which the distance from the focus to P is the same as the distance from the directrix to P. We have our axis of symmetry about which the parabola is balanced. We have our axis of symmetry right through here. The point of intersection of the parabola with its axis is called the vertex. The vertex of my parabola is where the line of symmetry intersects the parabola. Okay. Now, let's analyze parabolas with the vertex at the origin. We're starting out with our parabolas having a vertex at the origin. You can see your XY axes right here. I'm going to color them for our purposes so that we can see them a little bit easier in relation to what we're working with. Notice the vertex has been chosen at the origin and that F is on the x-axis. So F is over here on the x-axis. From the definition above, we know that the distance from a point on the parabola to the directrix is equal to the distance from the focus to the same point. So this point P is equidistant here and here. So this is the point on the directrix that is the same distance as this point on the at the focus. Using the distance formula, we can find the equation for this parabola. We know the distance from P to D has these coordinates. So we're going to use the distance formula, which is the sum of the squares of the differences, the square root of the sum of the squares of the differences. So from x, I have minus a, x minus a quantity squared, and then I'm going to have y minus 0 quantity squared. And then the distance of f to p, so I may have switched them. P to D is a and y, f to p. I think I got them switched. That's okay. We're going to go ahead and do, this would have been x minus a and y minus 0. F to p, p to d. Sorry guys. This are the coordinates I use, the difference from x to a, difference between x and a, and the difference between y and 0. And so over here we have x minus a negative a quantity squared, because this is a negative a, plus, and then we have y minus y quantity squared. Sorry, I started at the wrong point. That's okay, it's not going to mess anything up. We're going to get rid of the square roots by squaring both sides of our equation, and then look at what's going on inside. So we have x minus a quantity squared plus, and then y minus 0 is just y squared. Over here we have x minus a negative, so that'd be x plus a quantity squared. And then y minus y is just 0, so that's all that's left over here. On the left, I'm going to FOIL this x minus a, this binomial. When I FOIL that, I get x squared minus 2ax plus a squared, and then I still have that y squared. On the right, I have x squared plus 2ax plus a squared. Now we're going to move terms to solve for y squared. Okay, that's our work that we're going to do. We are going to rearrange, we're going to move terms so that we solve our equation for y squared. Because I see my y squared is my unique variable. Everything else is in terms of x's. So I'm going to start moving things over to the right. So I'm going to subtract this x squared, and I'm going to add 2ax, and I'm going to subtract a squared. When I do all of that, what I'm left with on the right is y squared, and on the on the left is y squared. I am absolutely directionally challenged today, if you guys haven't noticed. On the left, I have y squared. On the right, this adds to 0. I have 4ax, and that adds to 0. So here is the equation of my parabola that opens to the right. Y squared equals 4ax. Okay, let's take that to our next page. The equation of a parabola with vertex at the origin has a focus at a0, where a is positive. That equation for the parabola is going to be y squared equals 4ax. Now here's where we start getting into some more new terms and new definitions. We have a focus that is a units from 0, and then we have 2 points on the parabola that are at a2a and a negative 2a. When we combine those 2 points with a line segment, we're going to call that line segment the lattice rectum, or LR. So the lattice rectum is going to be a line segment that is parallel to the directrix. Remember, my directrix is capital D, and it goes through the focus, through F, parallel to the directrix through F. Let's do some graphing. Now, this is my equation of my parabola, and we are just going to do a very basic one where the focus is at 1, 0. My focus is at 1, 0. That means A is 1. So I have an origin at the vertex at the origin. The focus is at 1, 0. That's F. The directrix is going to be that same distance back the other way, and it is going to be parallel to the lattice rectum, perpendicular to the axis of symmetry. So my directrix, if this focus is at positive 1, my directrix is going to be at negative 1. So this is my directrix, D. The equation for D is x equals -1. My equation for my parabola starts as y squared equals 4ax because I know the focus is 1 unit over, that means a is 1. So that would be 4 times 1 times x. So my equation of my parabola is just y squared equals 4x. My lattice, well, let's find some points on my parabola. If x is 1, I have y squared equals 4, so I go up 2, down 2. So let's do that. Let's do x is 1, I go up to 2 and down to 2. If x is, let's say, 2, that is 8. That's not a perfect square root. If x is 3, that's 12. If x is 4, 4 times 4 is 16. Square root of 16 is 4. So if I go out to 4, I would go up to 4 and down to 4. So there is what my parabola will look like. Now remember that my lattice rectum goes through the focus, up and down to meet the parabola. So this is my lattice rectum from here to there. The distance from the focus to that end point of the lattice rectum is 2a, both directions. So with A1, this is 2 units up and 2 units down. My axis of symmetry is where I can fold the parabola. Axis of symmetry is at the x-axis, y equals 0. The axis of symmetry is perpendicular to the directrix. It goes through the vertex and the focus. The distance from the vertex to the focus is the same as the distance from the vertex to the directrix. And that distance, A, when I move to get the lattice rectum from the focus, I will go up 2a and I will go down 2a to find the endpoints of the lattice rectum. That is a very basic parabola that opens to the right. Let's do another one. Let's analyze this next equation. The form we have of our equation, y squared equals 16x, is my equation for a parabola with a vertex at 0, 0 and a focus at a 0. Oops, sorry. So we know, based on the form of my equation, that we have a parabola that opens to the right. So because of that, we know that the vertex is at the origin. My equation is y squared equals 4ax. And I have 16x, that means 4a has to be, therefore 4a has to be equal to 16, which gives me a value of a as 4. So let's think about what's going on. We've got based on the form of our equation, we know my vertex is at the origin, and we are opening to the right. My focus can be found at a0, and we found a value of a as 4. So I'm going to go over 4, and there is the focus. That means my axis of symmetry is still on the x-axis, y equals 0. I know my focus is here, so my focus is at 4, 0, and that focus also allows me to find the directrix. It's going to go back the other way. So I can say that my directrix is going to be here at x equals -4, because it is the same distance from the origin as the focus, just in the opposite direction. Now we need to find the 2 points of the lattice rectum so that we can draw our parabola. Well, we know that A, the easiest way I think to do this, so for the lattice rectum, I know that A is 4. This distance is 4 between the vertex and the directrix is the same as the distance between the vertex and the focus. And I know to find the endpoints of the lattice rectum, I'm going to go up and down 2A. So I'm going to go up and down 4 from the focus. So from the focus, I go up 4 and I go down 4. And that gives me the graph of my parabola. And there's my lattice rectum. Oh, I just did that wrong, didn't I? Oh, guys, y'all are at home just cringing along with me. Looking in, we're 16 minutes in. We are absolutely going to do that. I said, I sat here and did this. A is 4. I said my lattice rectum goes up 2A. 2A is not 4. If A is 4, 2A is 8. Cringy, cringy, cringy moments, guys. Okay, I do not have whiteout, which I really, really should. We are going to fix it. We are going to fix it. Instead of going up to 4, we're going to go to 8. That's my lattice rectum. Lattice rectum goes to 8, which means my parabola opens much wider than I originally said. Alright, so this is what would happen if we were in class. I would make this mistake, but you would have caught it much sooner. Because I said it and then I just didn't do the math right. 2 times 4 is 8. 2 times 4. So from the focus, I go up and down 4, which means from the focus, I'm going to go up 8 units, and down 8 units. The lattice rectum goes all the way through the focus to a point on one side of the parabola, through the focus to a point on the other side of the parabola. Important things to make note of to make sure you have straight now that I've tried really hard to confuse you. The lattice rectum is parallel to the directrix. They are equidistant from the vertex. They are both perpendicular to the axis of symmetry. The axis of symmetry also goes through your vertex of your parabola, which we said was at 0, 0 because of the form of our equation for our parabola. Another way to find the equation of the lattice rectum is say, you know what, we know the focus is at 4, so x is 4. At the focus, our x coordinate is 4. So if I take my equation, y squared equals 4ax, well, we know that a is 4. And if x is 4, we can solve for y squared. So 4 times 4 is 16 times 4 is 64, which means y squared is equal to 64, and y is equal to plus or minus the square root of 64, which is a positive and negative 8. So that's 2 different ways to find the endpoints for your lattice rectum. Okay, I promise to try to do better. Now, on the next page, this is probably really, really good that I did this. I've already filled in our chart. I want to strongly encourage you to go ahead and fill in yours. Pause the video, go ahead and fill in your chart. Notice that we've got our XY axes, and we have moved our vertex of our parabola away from the origin, but the vertex still falls on one or other axis. So we have our XY axes now in blue. The first equation for our parabola, y squared equals 4ax, that's the one we've been working with. I lied. We haven't moved away from the origin. We have just, we're turning which way we do it. So the origin, when we move away from the origin, that's 2 pages on around. When we move away from the origin, we know we've moved away from the origin because we have values for h and k, so that we don't just have x squared and y, or y squared and x. We have x minus something, y minus something. That shifts our vertex horizontally and or vertically. Right now, we are just turning our vertex around the origin, so that our parabola is faced in a different direction. So for this first one, equation A, y squared equals 4ax. I know if it's y squared, that it's either open left or right. It's open to the right if I have a positive 4. It's open to the left if that coefficient is negative. So this is A, this is B. We are going to draw our directrix. You know what? I messed up my color coding too. There's my x, y axes. Here's my directrix in purple. This is D, is negative A, where F is a positive A. On this next one, my directrix is at positive A, because my focus is at a negative A. So when I'm looking at my directrix and my focus, they're going to be on opposite sides of the vertex. My vertex is here, still at the origin. My vertex is at the origin. My focus has moved. My focus is on one side of the vertex, my directrix is on the other. My focus is on one side of the vertex, my directrix is on the other. As long as I have the equation set to y squared, it's opening to the right or to the left. If this is a positive coefficient, it opens to the right. If this is a negative coefficient, it opens to the left. Now remember I talked about college algebra and our parabolas that we would graph there, and I said we always had y equals x squared. Well, our equation looks a little different here for C and D. But we still have the x squared. If you have an x squared, you know your equation opens up if that's a positive coefficient, and it opens down if that's a negative coefficient. Once more, your directrix is on one side equidistant from the focus that is on the other side. So the line that is your directrix is equidistant from the focus. Here's my vertex in the middle. The distance from the vertex to the focus is the same as the distance from the vertex to the directrix. Vertex to focus, that is A units, and that is also A units. That is A units, that is also A units away. Let's use these equations to figure out how to graph some parabolas. And I'm going to do my best to not get messed up. Okay. You know what, let's write our equations down here. This one is going to be a y squared because it opens to the right. Y squared equals positive 4ax. This one opens to the left. It's a y squared equals a negative 4ax. C opens up, so it's an x squared equals 4ay. And this opens down, so it's an x squared equals a negative 4ay. Those are my 4 equations for a parabola whose vertex is still on the origin. This is the one that we worked with already. The equation that we're going to work with this time is x squared equals negative 8y. Because of the form of the equation, I know that I have a parabola that opens down. It's set to x squared and it has negative. And the vertex is going to be at the origin because I don't have x plus or minus, y plus or minus anything. So let's go ahead and start sketching that. We've got a parabola whose vertex is at the origin, and we know it's going to open downward. Well, what else do we know? We can find the focus because our equation, our basic equation, opens down, starts as x squared equals negative 4ay. So that tells me that this negative 4a is equal to a negative 8. Negative 4a is equal to a negative 8. Therefore, a is 2. So the distance from my vertex to F and the distance from the vertex to the directrix, 2 units. My focus is going to be open. I know my parabola opens down, so my focus is going to be at negative 2, or 0, negative 2. I got it backwards. 0, negative 2. So my focus is going to be 2 units from the vertex, and the parabola opens down. My directrix is also 2 units from the vertex in the opposite direction. So directrix D is going to be the equation y equals a positive 2. Y equals 2. That's my directrix. So we're going to have a parabola centered at the vertex, 0, 0, that opens downward. We know that from the form of our equation. We didn't have to do any math to figure that out. We found the value for A to tell us where the focus is and where the directrix is. The next thing we need to figure out is 2 points that determine the lattice rectum, because that's what else we're asked for. The 2 points that determine the lattice rectum are going to be on a line out from the focus parallel to the directrix. They're going to be on this line. How far out do we move? Well, we're going to move from the focus to A in both directions. This is A, this is A, this is going to be 2A. Well, if A is 2, that means to get to the lattice rectum, I'm going to move 2A this time, which is going to be 4. So I'm going to move out from F 1, 2, 3, 4 units in both directions. That's where the lattice rectum is going to fall. So the lattice rectum is going to be 2A. So A is 2. That's going to be 4 units from the focus, plus or minus 4 units from the focus, parallel to the directrix. The other way to calculate that is to plug in my value for the focus, negative 2, for y. From the focus, 0, negative 2, I get that y is equal to negative 2. So I would do x squared equals negative 8 times negative 2 gives me 16. So x squared equals 16. That means the x-coordinates for the endpoints of my lattice rectum, plus or minus square root 16, plus or minus 4. X-coordinate positive 4, x-coordinate negative 4. I connect those points to my vertex to form my parabola. So the endpoints of the lattice rectum, the 2 points that are the endpoints of the lattice rectum, are at negative 4, negative 2, and positive 4, negative 2. All right, let's look at the next page. Find the equation of a parabola and graph it. So we're given some information. We're told that we have find the equation of the parabola with a focus at 0, 5 and a directrix at line at y equals negative 5. Well, my focus is at 0, 5, so I'm going to go over 0 up to 5. That's my focus, and my directrix is at negative 5. So we know some stuff. This is D. We know that the vertex is halfway between the focus and the directrix, and it's on that line of symmetry. So axis of symmetry is here because it's perpendicular to the directrix. We know that A is 5. So we know A is 5. That tells me that my vertex is at the origin because it's halfway between the focus and the directrix. And we know A is 5. So that helps us out. Our parabola, if our focus is here and our vertex is here, our parabola is going to open up. The equation of my parabola that opens up is x squared equals 4ay. We know it's an x squared because it opens up or down, and we know since it opens up, it's a positive 4ay. Alright, so if a is 5, then I have x squared equals 4 times 5 is 20y. There's my equation for my parabola. That's what I was asked to find. That's a, the equation of the parabola. Then we're supposed to graph it by plotting the vertex and the 2 points that determine the lattice rectum. Well, the 2 points that determine the lattice rectum, remember they are 2a out plus or minus 2a from my focus. Well, a is 5, so they are going to be plus or minus 10 units from the focus. So I'm going to go out 10 to the right, and I'm going to go out 10 to the left, and that's going to be the endpoints of the lattice rectum. Now my focus is at 5 up, so I have negative 10, 5, and I have positive 10, 5 for the endpoints of the lattice rectum. The other way I could have found that is to say, you know what? I know that I'm going to be going 10, so y is going to be, no, y is going to be 5. I'm sorry, y is going to be 5. So at the lattice rectum, y is 5. So that would be x squared equals 20 times 5. So x squared equals 100. To solve for x, I take the square root and I get plus or minus 10. So my x coordinate is going to be positive and negative 10 at that y coordinate of 5. And I sketch my parabola. Alright, finding the equation of a parabola and graphing it one more time before we move our focus, our vertex away from the origin. Find the equation of the parabola with a vertex at 0, 0. Its axis of symmetry is the y-axis. Axis of symmetry is the y-axis. That means immediately we know it's going to open either up or down. Here's my axis of symmetry. Its graph contains the point -1, -4. My graph contains the point -1, -4. So if it contains the point -1, -4, it's also going to contain the point 1, 4, because -4, because that is the axis of symmetry, right? We also know that vertex is at the origin. So my vertex is here. So right here is the graph of my parabola. We need an equation though. Well, let's figure this out. If we don't have a focus and we don't have a directrix, this is all we have. So let's see what we can do with that. We know that if we are opening down, our general equation is x squared equals -4ay. And we have a point that we plotted. So we can plug that in. If x is -1, that's -1 squared equals -4a times -4. So 1 equals 16a, which means my value for a is 1/16. Okay, so that helps me out. My focus is inside the parabola a units from the vertex. So my focus is going to be at 0, -1/16. My directrix is the other direction from the vertex, perpendicular to the axis of symmetry. So the equation for the directrix is going to be y equals a positive 1/16. So that's some good information for me. When I go back to my general form from my equation, x squared equals -4ay, and I plug in 1/16 for a, my equation for this parabola is x squared equals a -1/4 y. So that's my equation for my parabola. I know my focus is right here, and I know my directrix is right here. 1/16 is really hard to draw, right? What about the endpoints for the lattice rectum? Well, they are going to be from, they are going to be 2A out, right? So they're going to be down 1/16. So the endpoints for the lattice rectum are going to be down a negative 1/16. And we need to figure out what that x coordinate is. Well, A is 1/16. 2A is going to be 2/16, which is plus or minus 1/8. So from the line of symmetry where the focus is, I'm going to move to the left 1/8 and to the right 1/8. So to the left 1/8, to the right 1/8. Those are going to be the endpoints calculated for my lattice rectum. And I can sketch it kind of sort of, but it's really hard to see. So we did all of those things. We found the focus in the directrix, we found our vertex, we found the endpoints for the lattice rectum, and we have graphed our parabola. I don't always do things, obviously, in the order that they give them to me, but we get them all in. Okay, now we are going to finally move our vertex away from the origin. I really feel bad about misstating that earlier, but we are back on track. So we have a parabola with a vertex at HK, not at the origin. I filled this in again. I did a better job of paying attention to what I was sketching in blue. I've got my XY axes sketched correctly this time, drawn over correctly. Okay, I have 4 different equations for parabolas that have been moved, where the vertex has been moved away from the origin. Here my vertex is up there in the right, in the first quadrant. Here my vertex is in the first quadrant still, but I am facing back to the left. This one's open to the right, this one's open to the left. This one is opened up. Let's just trace our parabola. We've got one opening to the left, opening to the right, opening up, and then opening down. That's what's important. It's not what quadrant our vertex is in, it's where my parabola is opening. So if my parabola is oriented on the x-axis and opening to the right, this is the equation for that parabola. We still have a y squared if it's open to the right or the left. So this is going to be y minus k squared equals 4a times x minus h. So I've got a horizontal shift and a vertical shift away from the origin. Then B is my parabola that is open to the left. It's still a y minus k squared, but this time it's a negative 4a x minus h, because that flips it over, opens it back to the left. For these two, open up and down, they are oriented on the x-axis if it's going to open up or down, which means I have an x square, not a y square. So we've got A, B, C, and D. This is C. We have x minus h quantity squared. That x squared tells me it's going to open up or down, one or the other. Positive 4a tells me it opens up. For D, when I have x minus h quantity squared with a negative 4a, we're going to open down. So all I did here was recopy the equations that are in the chart there. Go ahead and pause the video, make sure that you get that information written down, and let's work with it. Example 6, we're going to find the equation of a parabola, and it gives me a vertex and a focus. Okay, so I'm going to start with my graph. I'm going to graph what I know. I'm going to graph my vertex, and I'm going to graph my focus. My vertex is at -5, -1. So x is -5, y is -1. Right there. That's my vertex. We're going to say vertex. My focus is at 2, -1. 2, -1. There's my focus. Well, the location of the vertex and the focus tells me immediately that my parabola opens to the right. If it opens to the right, this is the equation I'm working with. Y minus k quantity squared equals 4a times x minus h, because my parabola opens to the right based on these 2 points that I was given. My parabola, my vertex, shifted left 5 and down 1. So that makes that x plus 5, because I plug in that negative 5, and y plus 1, because I plug in that negative 1. I still need to know what a is. I need to figure out a. Well, a is the distance from the vertex to the focus. Well, if my vertex is at negative 5 and my focus is at positive 2, a is 7. The distance from the vertex to the focus tells me that a is 7. That gives me my equation for my parabola in final form as x plus 1 quantity squared equals 28, because 4 times 7 times x plus 5. There's my equation for my parabola. Okay, let's work on some other stuff that we know. Well, we know that if our focus is 7 units to the right, our directrix is 7 units to the left. So negative 5 minus 7 puts my directrix at negative 12. So D is at x equals negative 12. We know that my axis of symmetry is at negative 1. Axis of symmetry is at y equals negative 1. What else do we need? We've got focus, we've got vertex, we need our lattice rectum, we need our endpoints for our lattice rectum in order to figure out where to graph the rest of my parabola. So let's do that. Let's do the lattice rectum. I'm going to go up and down 2a from the focus because it's going to be on the same line as the focus parallel to the directrix. We said a is 7, so plus or minus 14 from, well, my focus is at 2, negative 1, from negative 1. So if I go up 14 from negative 1, I go up to 13. Yep, right there. And then, so that is at 2, 13. And then if I go down 14 from negative 1, I'm down at negative 15. So negative 12, 14, 15. So that's going to be 2, negative 15. And those are the endpoints of my lattice rectum. There's my lattice rectum right there. And I sketch the parabola from the vertex up to that lattice rectum, down to this endpoint of the lattice rectum, and it keeps going out. Alright guys, let's look at our last page of notes. I apologize that this is a longish video. Analyze the equation by doing the following. So we're given an equation and we're asked to first find the vertex. Now we've got a y square. When we have a y square equation, we know that this is going to open either to y square is going to be open either to the right or to the left, correct? Yeah, open either to the right or to the left. Because if we have a y square, it's either going to open to the right or to the left. So we need to figure out which one. Let's do a little bit of arithmetic. We're going to want to get it into the right form so that we move, we're going to complete the square on the left with our y. We need to move that x out of the way. So we have y squared plus 4y, and then we're going to complete that square, is equal to positive 4x when we move that over. And then I need to complete the square. So half of b is 2, and 2 squared is 4, so I add 4 to both sides. Right here, I'm going to have my factor as x plus 2 quantity squared. That's what I wanted. Over here, let's pull out that common factor of 4 so that I have x plus 1. So we've got our equation in the right form, the correct form. This lets me know my horizontal and vertical shifts, and it can help me calculate A when I get ready for that. Right now we're just finding the vertex. The vertex is going to be at -1, -2, and we know this equation opens to the right because it is a positive coefficient here. Find the focus. Well, what is A? A, if we've got 4, to find the focus we need to know A. This, in my standard form of my equation, is 4A, and 4A is equal to 4, which means A is 1. So from my vertex at -1, -2, I'm going to have a parabola that opens to the right. From the vertex, I move to the right 1 to get to the focus. So this this focus is at 0, still down at -2. So there's my focus, vertex and focus. I have to kind of sketch it so I can see what's going on. The next thing it asks me to do is find the directrix. Well, the directrix is in the other direction from the focus, and it's going to be parallel to my lattice rectum, perpendicular to my axis of symmetry. If my vertex is at x is -1, my directrix is going to be 1 in the other direction. So x equals h minus a, so -1 minus 1. So my directrix is going to be the line x equals -2. All right. Now we have an application problem. Very last thing in this section is an application problem. There are a lot of applications for parabolas, and it asks us to name at least one. Well, anything where I focus a beam, so a searchlight uses a parabola, flashlights are going to use parabolas, headlights in your car, that inside your headlight is shaped like a parabola. Solar energy makes use of parabolas. Telescopes make use of parabolas. So that's way more than one application for parabolas. Another example is a satellite dish. You don't see satellite dishes. Well, you do for like DirecTV. You see the little satellite dishes. Those are shaped like a paraboloid of revolution, a parabola. The signals emanate from a satellite, strike the surface of the dish, and are reflected to a single point, the focus, where the receiver is located. Now we have a dish that is 12 feet across at its opening and 5 feet deep at its centers. Draw a sketch, and it suggests that you locate it at the origin, opening upward, with the positive y-axis as the focus. So we have a satellite dish, and it's going to look like this. We know that at its opening it is 12 feet across, and it is 5 feet deep at its center. So this point is 0, 5, and this point, if it's 12 feet across, this point is at 6, 5, and this point is at -6, 5. Now, that's not the lattice rectum, because this is not the focus. This is the opening. We need to figure out the focus, where that receiver should be placed. That's what we're looking for. The receiver is going to be placed at the focus. Okay, if our parabola is centered on the origin and it opens up, then the equation of that parabola is x squared equals 4ay. If you didn't remember that, you can look back at that correct chart. Well, let's just use this point and plug in. So if we plug in this point, that would give us 6 squared equals 4a5, 36 equals 20a, which means a would be 36 divided by 20, which simplifies to be, I divide both of those by 4 and I get 9/5. A is the distance from the vertex to the focus. Well, the distance, therefore, is going to be 9/5. All of our measurements are in feet. So my focus, my receiver, is going to be 1 4/5 feet above the base, or above the center opening of our satellite.